Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the first question from the mid-year examination, which was written in the province of Gauteng in the year of 2024. Please do expect a total number of 8 videos, since the question paper had 8 questions in total. That simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the videos to your peers so that they may have the same edge as well. And please guys, do help us grow the channel by just subscribing. Okay, question 1 guys is a multiple choice question. All I have to do is to select the most correct option I'm given below. Nah? Okay, consider the condensed structural formula below. If ever guys are given a condensed structure of an organic compound, please do draw a structural formula first. So that's CH3, CH2, and then CH2 with an OH. There's an OH on the terminal carbon. Then we have our hydrogens over there. Hydrogen, 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 hydrogen. So I can see that I have an alcohol. And I'm being asked, what is the functional group of my alcohol? The functional group, guys, for alcohol is always hydroxyl group, né? Because carbonyl group is for ketones, formyl is for aldehydes, carboxyl group is for carboxylic acids, né? Then hydroxide belongs to alcohols. Okay, consider the compound below. Okay, which one of the following is the IUPAC name of this organic compound? Okay, let's name this guy over here. Né? Since guys, I can see that I have a hydrocarbon which is saturated. Saturated simply means it has single bonds between adjacent carbons. Né? Okay, so that means whenever I number my carbons, I must start counting from the terminal that is closer to the side chains. Are you together? So the left hand side is closer to the side chains. So this will be my parent chain over here. Are you together? Or you can say this is a parent chain. It's still the same thing, guys. Né? It doesn't matter. Okay, so that will be carbon number 1, carbon number 2, carbon number 3, 4, 5, 6, and 7. Né? Okay, whenever I know that my parent chain rather has 7 carbons, so the prefix of my parent chain has to be hept. Are you together? The prefix has to be hept. I can see that I have a side chain with 2 carbons on it. So I have an ethyl, and then I have side chains with only 1 carbons. That means I have ethyls in carbon number methyls rather in carbon number 2. Né? So whenever guys I name this compound, I must start by mentioning these side chains, and I must mention them in an alphabetical order. Because this one starts with an E because it's ethyl. It's ethyl, and these ones are methyl. Né? That means I must start by mentioning the ethyl. So I know that in carbon number 5, there's an ethyl over there, a side chain with 2 carbons. In carbon number 5, there's an ethyl, and then in carbon number 2.2, I have dimethyl. I'm saying 2.2 because I have 2 of them. I have dimethyl, right? And then since the parent chain have 7 carbons, so the prefix of my parent chain will simply be hept, and then the suffix will be ane, because I'm dealing with an alkane that has side chains. Are you together? So this is the IUPAC name of my compound, guys. So the correct answer will be C. Okay. And then we are told that ethanol, ethanoic acid, and ethane are compounds that are found in a laboratory. Arrange these compounds mentioned above in decreasing order of vapor pressure. In decreasing order of vapor pressure. Okay. The one with the strongest intermolecular forces, guys, will have the lowest vapor pressure. Are you together? And the one with the weakest boiling point will simply have a highest vapor pressure. So the they want us to mention the arranged compounds mentioned below in decreasing order of a vapor pressure. Okay, so the one that has a weaker intermolecular forces is ethane. So this will be listed first, number 1, and then we have ethanol, ethanol, and ethanoic acid. Ethanol is an aldehyde. So it has dipole to dipole forces. So obviously ethanol is weaker than ethanol and ethanoic acid. Why is it weaker? Because these two, they contain a hydrogen bond, which is a stronger intermolecular force. Okay, and then between ethanol and ethanoic acid, which one is the weakest between the two? Ethanol is the weakest. Why? Yes, both of them have hydrogen bonds, but ethanoic acid have 2 sides of hydrogen bond. So ethanoic acid has stronger intermolecular forces compared to these other compared to all the 4 compounds. That's why ethanoic acid will have a lowest vapor pressure but a higher boiling point. Since they asked us about vapor pressure, so that's why I'll mention ethane as number 1 because it has the highest vapor pressure. Ethanol is number 2 because it has a second highest, and then ethanol and ethanoic acid. The correct answer will be B. Which one of the following reaction types will be used to prepare ethene and propane from pentane under high temperature and pressure? Okay, we are breaking down large alkane, or rather hydrocarbon molecules, into smaller and useful molecules. Are you together? So this is cracking. So already these 2 are marked out. Are you together? And then we are told the condition of our cracking, that there's high temperature and high pressure as well. So that means this thing is not catalytic cracking, it's just a thermal cracking. Okay, and then the graph below represents the relationship between potential energy and cost of reaction for a certain chemical reaction. Okay, the heat of the reaction for the reverse reaction is the change in enthalpy. For the reverse reaction is just the heat of products minus the heat of reactants. Né? So if my reverse reaction starts here and ends there, that means the heat of the products is equal to 3 kilojoules, and then the heat of our reactants was simply 1 kilojoules. So this is just 2 kilojoules. Are you together? So this is why the correct answer will be A, positive 2 kilojoules. Okay, the equation below represents the decomposition of calcium carbonate. Which one of the following factors will not affect the initial rate of decomposition of calcium carbonate? Will not affect the initial rate, né? Okay, temperature does affect the rate of decomposition, or rather the rate of reaction. So we want a factor that does not affect the rate of reaction actually. So temperature does affect the rate of reaction, so this is out of the way. Using powdered calcium carbonate is also out of the way because you are increasing the states of division, or you can say you are increasing a surface area. So this does affect the rate of reaction. And then adding a catalyst by virtue of adding a catalyst, guys, you will speed up your reaction rate. And then if you just increase the mass of calcium carbonate, we will not increase the rate of reaction. Why? Because this guy over here is not in aqueous solution, or rather in gaseous form. Are you together? So we cannot find the concentration of this guy. Are you together? So this change over here will never increase the rate of reaction. Okay, and then now we are told that the reaction represented by the equation below reaches equilibrium. Okay, I can see it's an endothermic reaction. So if it's an endothermic reaction, I know that an endothermic reaction always absorbs heat. to form products. Are you together? Okay, now let's answer these questions. Which one of the following changes to the reaction mixture will change its color from pink to blue? Okay, whatever change that should happen, it should favor the forward reaction. If ever we add the catalyst, guys, there's no reaction that is going to be favored, but I know that the rate of the forward reaction will increase, and so is the rate of the reverse reaction will increase. Né? So adding a catalyst will not help us. Né? Okay, and then if ever we place the reaction mixture in a container with cold water, by using cold water, guys, we are trying to decrease the temperature. Are you together? And if, guys, the forward reaction is endothermic, that means the reverse reaction is exothermic. By decreasing temperature, I'm always favoring the exothermic reaction. So that means the color change will just occur from blue to pink, and that's what I do not want. Né? So this one is also incorrect. And then now let's check if ever we add a few drops of concentrated hydrochloric acid in the reaction. Whenever, guys, I add a few drops of concentrated hydrochloric acid in this reaction, I'll be actually increasing the concentration of my chloride ions. And by increasing the concentration, the equilibrium will just shift towards the right, or you can say, I will favor the forward reaction. Are you together? Whenever the forward reaction is favored, the color will change from pink to blue. So this is the correct answer. That's the correct answer, guys. Né? Because adding water in the reaction mixture will not do anything. So the correct answer is option C. Okay? The correct answer is option C. Okay, and then now we are told that the following hypothetical reaction is at equilibrium at 500 kelvins. Okay, so we do have our reactants. Okay, these are our reactants and products over there. Né? Okay, excuse me. The diagram below shows the molecules involved in this chemical equilibrium at 500 kelvins. Né? Okay, I can see that these are my products. Let me highlight my products. These are my products. Né? These are my products. Are you together? Because for my products I have A and AB. So I've highlighted my products in green. Okay. And then at 300, at the temperature, the temperature is now decreased to 300 kelvins. Now, the diagram below represents the same equilibrium mixture, but only at 300 kelvins. So the amount of products has decreased. Now we have fewer products. We have fewer products. Are you together? Initially we had 1, 2, 3, 4, 5, 6, 7, 8, and then now we have 1, 2, 3, 4. This simply means that, guys, by decreasing the temperature, the equilibrium has shifted towards the left, or you can say we have favored the reverse reaction. Are you together? So by decreasing temperature, we are favoring the reverse reaction. So this simply means that the reverse reaction is exothermic and the forward reaction is endothermic. Are you together? So the heat will be on the right hand side because the forward reaction is endothermic. Okay, which of the following statements is correct? The forward reaction is exothermic. Nope. The reaction, rather the concentration of AB lowers at a lower temperature. Yes, that's true. It lowers at a lower temperature. And then the forward reaction is endothermic. This is true. We just stated that the forward reaction is endothermic. Ne, guys? We would this one, guys, we know that it's true, ne? But we wouldn't know how to quantify the amount of concentration since you're not given numerical values, ne? So yes, it's true, but it's not like I cannot support it without using calculations. Are you together? But this one is a known fact because I've seen that by decreasing temperature, I'm favoring the reverse reaction. And I know that whenever I decrease temperature, I will always favor an exothermic reaction. Since the reverse reaction is favored, this simply means the reverse reaction is exothermic. And if my reverse reaction is exothermic, therefore the forward reaction has to be endothermic. That's why I'm picking C over there. Okay. Which one of the following is the correct description for a 10 mole per cubic decimeter hydrochloric acid solution? I know that hydrochloric acid is a strong acid, number one. So this cancels the options B and C. Are you together? I'm told that the concentration is just 10 moles per cubic decimeter. This amount of concentration, guys, is huge. Are you together? So this is a highly concentrated strong base. That's why the correct answer is D over there. Okay, and then we are told to consider the reaction. Consider the reaction represented by the following equation. Okay, which one of the following represents an oxidizing agent? Okay, so we have Ag plus and copper 2 plus. Let's go and check on our standard tables. Okay, I prefer using standard table for A, ne? So I'm looking for Ag plus and copper 2 plus, ne? Okay, the one, guys, which has a more positive EMF is an oxidizing agent. Are you together? The one with a more positive EMF is regarded as an oxidizing agent. Are you together? So Ag plus is our oxidizing agent. Ag plus is our oxidizing agent. Let's go and check over there. Oh, option A, Ag plus is our oxidizing agent. So that's how, guys, we're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you.